Hello friends and welcome back to my channel. We are at the lecture number 10 of this chapter mole concept, and we are almost at the end of the chapter. We're going to discuss the last topic of this chapter, which is called as concentration terms. So let's get started with the topic. The topic name is concentration terms, and this topic will last for a long time because it has too many concepts to do. So the topic name is concentration terms. And this topic is the basics, as the chapter name is, right? Some basic concepts of chemistry. So this topic is a concept which not only comes in this chapter, it comes in chapter number 7, chapter number 8 of class 11th, and then chapter number 2, chapter number 3, chapter number 4. I mean, it has lots of applications basically. So concentration terms. So in total, we have to study the following concentration terms. The first one is weight by weight percentage. The second one is weight by volume percentage. And the third one is volume by volume percentage, right? The fourth one is molarity. So we'll be studying them one by one. Today we may not be able to do both, all of that, but we'll do it in the upcoming series of lectures. Fifth one is molality. Molality. Sixth one is normality. Seventh one is mole fraction. Eighth one is ppm, and ninth one is formality. About formality, I'll just do a little thing. It's not that important also, but nevertheless, let's study about that. So today I'll be covering these topics. First, weight by weight percentage, weight by volume percentage, weight by volume percentage, molarity, and molality. So I'll be walking you through the basics of these concepts. So let's get started with the topic. So let's first do the first one, weight by weight percentage, or sometimes we can call it as mass by mass percentage. So mass by mass or weight by weight percentage is basically defined as mass percent. We can also call it as mass percent. So mass percent can be defined as mass of solute, okay, mass of solute by mass of solution by mass of solution into 100. That's how we can define it. Okay, that's the definition of this. So it is basically mass of solute by mass of solution into 100. That's the definition. Like for example, what exactly do you mean by 20%? If someone says, what do you mean by 20% NaOH? You must know how to decode this. So what do you mean by 20% NaOH solution? This means that 20 grams. Now they may have to say that, what exactly they mean by 20%. So they will write in bracket W by W. Okay. Now what exactly do you mean by 20% W by W NaOH solution? You must know how to decode this. I'm telling you over and again. If you really want to succeed in doing questions of concentration terms, you must succeed in decoding these small phrases. So 20% NaOH solution means 20 grams of NaOH is present in 100 grams of solution. This is something that you must remember. Okay, 20 grams of NaOH is present in 100 grams of solution. That's what it means. So mass of solute by mass of solution into 100. That's it. Moving on to the next concept, mass by volume percentage, or mass by volume percentage. What exactly is mass by volume percentage? So mass by volume percentage is defined as m by v percent or w by v. You may see, because in chemistry mass and weight is the same thing, not like physics. So what is weight by volume? It is the mass of solute by volume of solution into 100, into volume of solution into 100. That's how we do it. Now into volume of solution into 100. Let me give an example. Again, decoding is important. What do you mean by 15% HCl solution? Or I won't say sugar. Let me replace it with sugar because that seems more realistic, because sugar is usually solid, right? So what do you mean by 15% sugar solution? Weight by volume. So this will mean that it is nothing but 15 grams of sugar. Yes, can you do it with me? Yes, 15 grams of sugar is present in exactly 100 milliliter of solution. That's how we understand it. Okay, next one, volume by volume solution. So let's go to the next one, volume by volume solution. This thing that you might have seen a lot now because it's used in sanitizers. This is the concentration term that we use in sanitizer, percentage V by V. You might have seen, right, in a sanitizer bottle they write 70%. What does that mean? We'll decode that now. Let's see. So first the formula, W by W percentage. It basically means that it's the volume of solution, volume of solute divided by volume of solution into 100. This is the basic formula. But again, let's learn the decoding. So what is actually doing by 70%? This is something that will see in your sanitizer bottles also. Ethyl alcohol. They may write like this: 70% ethyl alcohol solution. What does it means? It means that 70 milliliters of ethyl alcohol or ethanol is present in 100 milliliters of solution. So in a solution containing 100 milliliters of solution, 70% is alcohol in it. That's what we mean by this particular point. Now, so first one is basically mass by mass, right? This is the one. See, mass by mass percentage. Second one is mass by volume percentage. Third one is volume by volume percentage, right? This is how we can do it. First one, second one, third one. Now the next term we have to study is molarity. Molarity. Molarity is defined by capital M. So what's the definition of molarity? So first of all, let's learn that. Molarity M is nothing but number of moles of solute divided by volume of solution into 100. I mean, not 100, in milliliters. You must remember this part. It should be in milliliters. It must be in milliliters. Liters. That's a very important criteria. So number of moles of solute by volume of solution in liters. Okay. So let's understand with an example. Again, let's try to decode something. Before that, what's the unit of molarity? Unit of molarity will be mole per liter. That's it. Now, what is that mean by 5 molar NaOH solution? If someone asks you, you must know how to decode. I'm telling you over and over again because in next lecture we'll be doing questions. So you must know how to decode these small terms. What is at least 5 molar NaOH solution? It means that 5 moles of NaOH is present in, yes, 1 liter of solution. It's present in 1 liter of solution. This is something that you must remember. Okay, next one. Molality. Since we are at it, let me tell you one more point. Molarity is temperature dependent. Why? Because molarity depends on volume and volume depends on temperature. That's why. So since volume depends on temperature, right, and molarity depends on volume, right? So we can say that volume will depend on temperature, right? Depends on it, temperature. Transitive property. If A is equal to B, B equals to C, so A will be equal to C. As simple as that. Next. So this is the last topic, molality, small m. See, that was with R, molarity, but this is molality. See, that's the difference. That was molarity, but this is molality, right? So let's talk about molality now. Molality denoted by small m. What is that is molality? See, As per the definition goes, molality is nothing but number of moles of solute, by mass of solvent in kg. Mass of solvent in kg. It should be in kilograms. That's an important criteria. Again, time to decode something. So suppose if someone says that I have 2 molar HCl, sorry, 2 molal. You have to read it different. How do we read it? 2 molal solution. 2 molal solution. How to read this? It means that 2 moles of HCl is present in 1 kg of solvent. In this case, it could be water. So 1 kg of water. That's it. That's how we can understand molality. Will it be temperature dependent? No. So molality with a small m is independent of temperature. Please understand, because mass doesn't depend on temperature, right? Like for example, my mass now is 75 kg. Then in 10 more degrees, I'll not become 25 kg, right? It doesn't depend on it. So mass is independent of temperature. Therefore, this will not depend on temperature. So we have discussed 5 concentration terms already. This one, volume, molarity, molality. Let's do a couple of questions and then we can wind up this video, because in the next lecture I'm anyway going to do lots of questions of higher level. This is just an introductory video, so let's do a couple of questions. A simple one though. So find the molarity of, find the following. First question, find the molarity of 1.8% weight by volume glucose solution. Suppose someone asks you this question, how do we approach this? Right? Another question, find the, this is molarity. Find the molarity of 1.8% weight by volume glucose solution. So I would want you to pause the video and try to attempt this question on your own. So please pause the video and do it. Okay, welcome back. Let's see how we can solve this question. So first of all, what is molarity? For molarity, we need two things. First one, number of moles of solute, right? That's what we need on numerator. As a denominator, we need volume of solution in liters. Volume of solution in liters. Now tell me, do we have any of this data given in the question? Sadly, no. You have to decode it. Excellent. So from this, let's try to decode few of the things. What's the first thing that we can decode here? 1.8 grams of glucose. Yeah, that's what we mean by 1.8% W by V, right? I have told you in the sometimes back. It means that 1.8 grams of glucose is present in yes 100 milliliters of solution, right? 100 milliliters of solution. Now 1.8 grams of glucose, meaning from this can you find the number of moles? Because see, we need number of moles on the numerator. So what is glucose? C6H12O6. The molar mass will be 180 grams. So how many moles do we have? Number of moles of glucose will be given mass upon molar mass. How to find moles? It's again there in one of my lectures. So I'll put one in I button on top of the video lecture so that you can access that video as well. So I'll put that for you. So it will be 18 into 10 to the minus 1, right? Divided by 180. So this is 1 by 10. So it will be 10 to the power minus 2. Right? We can write it as 10 to the power minus 3 exactly. We can write it as 10 to the power minus 3 because this will cancel by t 10. See, if you are really, you can do it like this, the simplest way. You can write it like this, 118 by 1800, cancel it, 1 by 100. That means 0.01. So number of moles is 0.01. What is the volume? So volume is 100 milliliters. See, 100 milliliter of solution. So from here we can find the volumes in liter. What is the meaning of 100 milliliters in liter? Excellent, 0.1 liters. So from here, what is the molarity? That is number of moles by volume. This will give me 1 by 110. So it will be 0.1. So 0.1 molar is the answer of this question. This is how you can decode and do questions of this type. I hope you understood. If not, you can rewind and see the video. Let's go to the next question, which is our last question for this lecture. So let's do another question. Find the molality of 40 grams of NaOH solution, NaOH dissolved in 1 kg of or 200 grams of water. 200 grams of water. How to do this question? It's a simple one, right? So first thing first, we have to write the formula of molality. What is the formula of molality? Molality small m is denoted by number of moles of solute, right? Divided by, yes, mass of solvent in kg. That's the definition. Now, what is the number of moles of solute? Let's find it out. So how to find number of moles when mass is given? Given mass by molar mass. NaOH, what is the molar mass? 40 grams. So you can find 23 plus 1 plus 16. That will be 1. How about the mass? 1. Number of moles 1. What is the mass of solid? 200 grams in water. So what's the mass in kg? 200 grams divided by 1000. So the answer will come out to be 0.2 kg. 0.2 kg. So moles on top, kg at bottom. The answer will be, yes, 5. So 5 molal solution. So that is how we can approach this question and solve this. In this lecture today, we discussed about weight by weight, weight by volume, volume by volume, molarity, molality. So that's it for this video. In the next lecture, we'll be doing some higher order questions of limiting rate, mole concept, and all these things combined. And then we have to also do the concentration term too. So we'll first do the concentration term 2, and then we'll do with the questions and all. I hope this video is helpful. Please like the video, subscribe to my channel, and share it to your friends. So with this, we'll wind up. Thank you so much.